Hello and welcome to our new unit on circles. So this unit is, I'm going to put chapter, circles and tangent lines. This will be the first section. This can be split up into two parts because we're just going to talk about circles and their kind of like components, circles and tangent lines. So there's obviously a whole bunch of things that go into circles, as we've previously discussed in prior units. So here we're just going to start off with drawing a circle. Every circle can be defined. I'm going to call this C in the center, and a circle is defined as the set of points equidistant to a point, which is the center. Okay, so in this particular case, C is the center. All of these points that are on the outside of this are the set of points. Okay, so here we have our circle. We also have obviously components to circles, and I'm going to move the C above just to make this a little bit cleaner. I want to draw a diameter. I don't think this is worth mentioning what a diameter is or defining it, because we've talked about it before, a radius as well. But what is worth mentioning is, for instance, if we have, I'm going to draw this here. I'm going to name these. I'm going to call this 1A. I'm going to call this B. Call this C. If, for instance, we draw a segment from A to C, notice that it does not go through the center, but the endpoints are both on the circle. This is something new. So we actually we have a name for this. We call this a chord. A chord is a segment whose endpoints are on the circle. So, looking closely, this begs the question: we know that AC is a chord. Okay, so for example, AC is a chord. Which begs the question: is the diameter a chord? Well, thinking about this logically, the diameter goes through the center, and there should be an endpoint here just to show that. Are both endpoints on the circle? Yes, absolutely. So if you are wondering, yes. The diameter is a chord. The radius, however, is not. Now I'm going to start coloring this in. If you have a highlighter or some kind of colored markers, this is going to be helpful. I'm going to start highlighting these just so we know. Radius in red. Diameter in red. Radius. What am I doing? Diameter in red. Radius in orange. Just to kind of color code this and make this a little nice. And then I'm going to do in brown the chord. Now I'm only going to do this chord. I'm not going to do the diameter because I want to differentiate it. And we're going to have another definition here. Central angle. This is also something we talked about. A central angle is an angle whose vertex is the center of the circle. Okay, so if we, for instance, draw this here, and let's say put a 60 degrees here, we could say that, I'm going to do this in green, the central angle, I'm going to put that in green, is 60 degrees. Okay, so I'm going to draw another circle because we have more terms to talk about. So I'm going to call this, I'm also going to call this circle C. Okay. Now, I'm also going to put another piece here. I'm going to call this X, Y, and Z. Okay? And actually, no, X, Y, Z. I'm going to also call this 60 degrees. And we're going to talk about arcs and arc measures. So arc measures, we have 3 of them. Okay? Arc measures can be classified in 3 different ways. Semicircle, which hopefully you could piece together. A semicircle is half of a circle. And this is 180 degrees. We have minor arcs and major arcs. A semicircle is the pivoting point between a minor arc and a major arc. Meaning, a minor arc is, if this is the pivoting point, 180 degrees, a minor arc would be less than a semicircle or less than 180 degrees. A major arc would be greater than a semicircle. And arc measures are always equivalent or congruent to their central angle. Now, central angles, as we know, are in the center. Arc measures are actually on the circumference. Okay, so I'm going to draw the, highlight. I'm going to draw the semicircle in blue. So if I drew this would be the semicircle. Okay, then I'm going to draw the minor arc in purple. A minor arc could possibly be, for instance, from X to Y. It is less than 180 degrees. And in pink, I'm going to draw a major arc. Major arc would be greater than 180 degrees. So this would be something like X all the way around beyond Z, wrapping all the way to Y. And that's your major arc. Okay? So, when we're talking about arc measures, we have to put an M for measure. So for instance, if I want to talk about the semicircle, this would be just a measurement of XZ. Now this one doesn't quite matter because you're talking about 180 degrees. No matter which way you go from X to Z, it will be 180 degrees. Okay, so XZ would be equal to 180 degrees because the central angle is 180 degrees. Okay, but if we're talking about, let's say, XY, the measurement of XY, there's a difference between the measurement of XY and the measurement of XZY because, well, obviously one has 2 letters, one has 3 letters, but it also talks about direction. If there's ever 2 points in a arc measure, you are taking the shortest distance to that point. So if you really, really think about this, if I did this, and let's say, if I talk about XY, I would go take the shortest distance there from X to Y. I would not wrap around because that's not the shortest distance. This, however, tells you that you need to wrap around towards Z in order to achieve, it's pretty much calculate the full arc measure. So that is the difference between these two. They both start at X and end at Y, or vice versa, but a third point makes a big difference because we're talking about it's a difference between a major arc and a minor arc. So here we have 60 degrees for XY because that is the central angle. That means this is the arc measure of 60 degrees. XZY would be 360 minus that minor arc. So 360 minus 60 is equal to 300. So that is the arc measure for XZY. All right. The last thing we're going to talk about is arc length. We've talked about this in the past, but just as a refresher, arc length. And I'm going to use this circle so you don't have to copy a new one. Arc length is literally pretty much the length of an arc. Of an arc. Now, if it's a full circle, that would just be the circumference, 2 pi r. Okay, so just as a reminder, circumference is equal to 2 pi r, or pi times diameter. Oops, that's a triple pi. Okay, we need this in order to calculate, for instance, a semicircle. We know a semicircle, so here we're going to do 2 quick examples. Example, xz. Now notice this time, I'm not putting an m in front of this. That the difference is that this is not an arc measure. This is arc length. Arc length does not have the m. Well, the formula here, let's actually start with the formula. The formula is the central angle, or the arc measure, over 360 degrees times the circumference. Now I'm going to put pi times diameter just because it's cleaner, but just know that you're multiplying by the circumference. So in this particular case, the arc length would be equal to 180 degrees because that is the arc measure, or the central angle, over 360 times pi. And then let's give this a diameter of, let's say, 9 inches. If we have 9 inches here, then this would be pi times, let's give a radius of 9 inches. So that would give me 9 times 2 times pi, or 18. So the nice part is we know a semicircle is half of a circle. So if we know that this is 18 pi for the circumference, we should know that this is going to be, a semicircle would be 9 pi. And this where canceling kicks in. This becomes 1/2. Then we do 1/2 of 18 pi, which is equal to our 9 pi that we just talked about. Since this is measured in inches, we would do 9 pi inches. So xz, the arc length of xz would be equal to 9 pi inches. Last one. If, for instance, we did the major arc xzy. xzy. Well, we know that that is 360 degrees, or 300 degrees, 360 minus the 60. So we could say 300 over 360 times 18 pi, because that's still the diameter, or the circumference. We could cancel out and then simplify. This becomes 5/6 times 18 pi. I'm going to put this over 1 just to make this a little bit easier to understand. These simplify. 2 goes into both, so we have a 9 here and an 8 here. And then, since nothing else simplifies, we could just multiply across. 5 times 9, 45, so 45 pi. 8 stays in your denominator, and this is here, and this is our answer. So xzy, the arc length, will be equal to 45 pi over 8 inches. All right, that's all I have for you today. If you have any questions, please let me know, and I will see you in the next one. Bye.